The topic of the lesson today is forces on a pulley. So what we're taking a look at is we've got a cart right here. And this cart is attached to a rope to a mass right here. And this mass is being held over a pulley. Now what's going to happen if this weight is allowed to free fall? What is the acceleration going to be of this cart? We're assuming right now there's going to be no friction. The first thing we're going to do, just like we do with every question here in physics, is we want to draw a free body diagram. So we'll do the cart first. Now our cart is a mass of 0.8 kilograms. What forces can be affecting here? Well, if we draw in here, we know there would be a force of gravity. And every time there's a force of gravity on a surface, there's a normal force. We're going to call this the tension in the wire. We'll call back here force of friction, even though we know it's going to be equal to 0. So there's our cart free body diagram. What can we start to put numbers to? Well, we can start to put numbers to the force of gravity here. We've got our force of gravity is equal to mass times acceleration. The mass is 0.8, and the acceleration is 9.8. And this means the force of gravity in this particular case is equal to 7.8 newtons down. Now, if the force of gravity is 7.8 newtons down, our force normal has to be equal to 7.8 newtons up, because the cart is neither leaving the surface nor falling through the surface. Now, we've drawn a cart for our free body diagram for the cart, but we haven't done one yet for the weight. So let's do that. We've got our mass right here. What forces are affecting this right here? We've got the force of tension. Oops. That needs to be the force of tension. And we've got our force of gravity yet again. Yet again, force of gravity is equal to mass times acceleration. Our mass in this case is 0.2 kilograms. And our acceleration is 9.8 meters per second squared. This gives us 1.96 newtons of force down. So this is the information we have right now. Where this question becomes a little bit trickier is we need to look at the force tension. How are these two values connected? Well, let's take a look here at our picture. If the cart right here is being dragged this way and then down, really what's happening is that this force of tension is the same value as this. And this force tension is dictated by this force gravity. So really what's moving the cart? It's this tension, this wire right here. So now we need to look at the net forces in the horizontal direction. Now that we figured out our free body diagrams, we now need to take a look at the question as a whole, because we've looked at the two different pieces individually, the cart and the weight. Now when I'm doing these questions here, I try to look at it as being one giant system, so that this cart here is connected with this weight here. Now how are they connected? Well, let's look at our free body diagrams. We know the wire, the force of tension, is connected to this wire here, which is the force of tension, because we know this cart is being pulled over and down. So really the way you want to think about it is that the force that this cart is feeling is actually just from this force of gravity. So when we're trying to figure out our net forces horizontally, the only one that we're really interested in is the force of gravity from the weight. So when we plug that in, we know the force net horizontally on the cart is 1.96 newtons. We also know that net force is always equal to mass times acceleration. So let's combine these two equations here. This is where this question starts to become a little bit tricky. What do we put down here for our mass? Well, let's yet again take a look at the picture we have. we've got the mass of the cart, but we've also got the mass of the weight. And both of these things are going to influence how quickly this cart is going to travel. So therefore, the mass that we're going to put in here is the mass of the cart plus the mass of the weight times the acceleration is equal to 1.96. Now let's start to put some numbers in there. 0.8 plus 0.2 times acceleration is equal to 1.96. So 1.0 A is equal to 1.96. So therefore, the acceleration of this cart is 1.96 meters per second squared to the right, because the cart is traveling to the right along the table. So for our next question, what we're going to do, so let's work through our next example here. It's still the same diagram, still the same masses. What I've changed this time is now you've got a coefficient of 0.2. Now, how is this going to affect things? Well, yet again, let's draw our free body diagrams. We've got our cart here, 0.8 kg. We've got our force of gravity, which is mass times acceleration. We've got a normal force. We've got the force of tension in the wire. And we've got the force of friction. Let's start to put some numbers in here. The mass of the cart is 0.8. And we know the acceleration due to gravity is 9.8. Therefore, that is equal yet again to 7.8 newtons, which means our normal force is equal to 7.8 newtons. Now, this is where it becomes important because we want to figure out the force of friction. So, the formula is coefficient of friction is equal to the force of friction over normal force. If we plug the numbers in there, it is 0.2 is equal to force of friction, still unknown, but normal force is 7.8. So when I put that into my calculator, that becomes equal to 1.6 newtons. That is my force of friction. That's important information, but we're going to hold on to that for just a moment and come back to it. We still haven't done our free body diagram for the weight here. So we've got our mass here of 0.2 kilograms. You've got the force of gravity, and you've got your force of tension. Force of gravity is mass times acceleration. And this is identical to the last question we did, so that's going to be equal to 1.96. Now we need to do our net force equation. And this is where the question is also a little bit different from the previous one. Our F net in the horizontal is based upon two things: your force of tension and your force of friction. So we've got the force of tension being equal to 1.96, because that's the tension being produced from the pulling of the weight. So that is newtons to the right. And we got the force of friction, which is equal to 1.6 newtons, which is acting to the left because friction opposes the direction of motion. So when we put that out, that is equal to 0.36 newtons. So we now know that our net force is 0.36 newtons. We also know that to figure out net force in the horizontal, that is also equal to mass times acceleration. So let's put these two equations together. Mass times acceleration is equal to 0.36 newtons. Now, because the mass of the cart and the mass of the weight affect how much this is going to accelerate, we're going to add both masses in there. 0.8 plus 0.2 times acceleration is equal to 0.36 newtons. That's going to become 1.0 times acceleration is equal to 0.36. Therefore, when we figure out our acceleration, that is equal to 0.36 meters per second squared to the right. Now, the next example I want you to try on your own. Hit pause, and then you can come back to it. This time, I am going to have a table here, and I've got my cart, and it's got a mass of 1.5 kilograms. And we've got my pulley right here, and the wire is going to go over, and it is going to be attached to a mass of 0.5 kilograms. Now this time, I'm going to tell you that the coefficient of friction is equal to 0.6. I want you to figure out A, if there's an if it moves, and if B, if so, what is the acceleration? So hit pause now and try this question. So the first thing we do anytime we get a question like this is we're going to draw free body diagrams. We have to draw a diagram of our cart, and we have to do it of our mass. So let's do the cart. 1.5 kilograms. We've got the force of gravity, we've got normal force, we've got force of tension, and we've got force of friction. Let's start to put some numbers into that. We've got gravity is mass times acceleration, 1.5 and 9.8. And that becomes equal to 14.7 newtons. Therefore, our normal force, because it's still staying on the table, is 14.7 newtons. From here, we can figure out our friction. Coefficient of friction is equal to force of friction over force normal. I told you earlier that the coefficient of friction is equal to 0.7. So that's equal to force of friction over 14.7. And when we put that into our calculator, and that is equal to 10.3 as your force of friction. Next thing we're going to talk about is the forces on this mass right here. So 0.5 kilograms. We've got the force of gravity, and we've got the force tension. That's equal to mass times acceleration. So 0.5 kilograms. So we've got our force of gravity right here, and that is equal to mass times acceleration. Our mass is 0.5. Our acceleration is 9.8. And that is going to be equal to 4.9 newtons. So now let's think of this system as a whole. Our F net in the horizontal is equal to two things. It's equal to the force tension, which is produced from the dropping weight, and your force of friction. We know the force tension is equal to the force of gravity, so we've got 4.9 newtons to the right, but our frictional forces, if it was moving, would be equal to 10.3 newtons to the left. Since friction only works when something is moving, we can say that this cart will give us a negative, which would be 4.9 minus. So we've got negative 5.4 newtons to the right. This doesn't make sense. Friction doesn't cause something to move backwards. So as a result, this cart does not move. What I would ask you to do is in your textbook, you turn to page 135. And I want you to try questions number 1 and 2. And you can also try on page 156, number 39 and 40.